Hello, I thought we'd talk today a little bit about self-hosted services and public versus private cloud. And we have here the question, what is public versus private cloud? Cloud really means running an application on another computer, as opposed to running it locally on your own computer, a regular application like Microsoft Word or Excel or something along that line. Public cloud is an application running on a computer on the internet. So that's as opposed to private cloud. Private cloud is running an application on a computer inside your network that is accessed over the network. And cloud is also referred to many times as software as a service. Examples of commercial SaaS are Microsoft Office 365 and Windows 365, which is a fairly recent offering. Why use cloud at all? Well, applications don't need to be installed on every computer that needs the application. Data can be easily shared between multiple users because the application is on a cloud computing resource. There's only one copy of the application to be upgraded and maintained. Cloud applications can authorize and deauthorize users centrally. That is from the web application. Cloud applications are accessed via a web browser and better understood by the user community. Have you noticed that in recent years we've seen more and more applications that are actually cloud-based as opposed to being loaded and configured on an individual machine? So why private cloud? Public cloud instances are things like Amazon AWS, Google Cloud, Oracle, OCS, DigitalOcean, Linode, and others. And these cloud services are expensive. I mean, they run anywhere between $5 to $50 per month per instance that you may actually want to install and use. Personally, I have 40 self-hosted private cloud containers providing various services, functions, and tools. And even at $20 a piece, that would cost me $800 a month. Break-even return on investment based on that is generally less than a year if you buy your own infrastructure server equipment. Private cloud keeps you in control of your infrastructure and your data. That's something that a lot of people like, especially in this day of privacy concerns. The downside of private cloud is that eventually the hardware that you own becomes obsolete and you have to manage your own hardware, meaning that if you have breakages, you have to handle that by yourself. A hard drive dies, a server dies, that sort of thing. And the upside of public cloud is that it costs more, but you always have the latest hardware and the latest services available. And they basically have higher availability, which means that less things can affect it. An internet outage doesn't affect public cloud. A server failure doesn't affect public cloud. And power failure doesn't, because most public cloud data centers have extensive multiple power sources. So what are the requirements for private cloud? Well, a server, first of all, to run applications. Data storage in the form of disk space. A domain name. A reverse proxy, and then containerization, which either means a virtual machine or a LXD, or Docker container. And I make containerization a requirement for private cloud because otherwise you'd have to, if you had 10 services, you'd have to buy 10 pieces of hardware to host those services on. So that makes containerization very cost-effective and very practical. What do I need for a server? Well, it can be as simple as an old computer. In fact, you can even use a Raspberry Pi. although I wouldn't really recommend it because there's not much you can do. I personally set up a Raspberry Pi with 3 or 4 services on it, and it works okay as long as none of them require a high amount of CPU or a lot of disk I/O. Servers can be bare metal or virtual. Again, bare metal is having a server piece of hardware where everything, the app is loaded directly on it, versus a virtual application where obviously we're dealing with one of these virtual containers. Virtualized applications are always recommended for efficiency for the reasons I mentioned just a little while ago. Memory and CPU cores, I think, are the most important aspects of a virtualized application, because the overall hardware, if it's not doesn't have very much capacity, well, you can't expect your applications to perform very well. Storage I always consider to be secondary in terms of speed and even quantity, but it depends upon your particular personal requirements. A server should have one or more Ethernet adapters and not be used over Wi-Fi. Wi-Fi is fine for your home tablets and even home computers, but when you start hosting an application, put the server directly connected to your infrastructure via Ethernet, not being used over Wi-Fi, that is. And finally, UPS backup power. So the presumption is if you go out and you host a web server, we're hoping that that web server is available most of the day and night. And if you have power glitches, you won't want your entire infrastructure at home to have to reboot before they come back up. So UPS backup power is recommended not only for availability, but also to be kind to the equipment. I live in the city of Houston, Texas, and we kid around about Houston's power company being Houston Spark and Flash. The only thing you should have connected up to a UPS unit is anything you care about. Pretty much means everything, everything electronic. So choices for a private cloud server. Well, an old quad-core computer with 16 gigabytes of memory or more. So I don't say a dual-core computer because if you got more than one container running on something, you're pretty typically going to require a little bit more compute power, and more cores is better. More memory is obviously better, but that's all based upon affordability. I found out a sweet spot for an entry level of getting into a private cloud server would probably be a minimum of about 16 gigabytes of memory. And you can maybe have about, I don't know, if they were all LXC containers or LXD containers, you might be able to host, say, 10 containers on something like that. But it all kind of depends on the requirements of the individual applications. So a new computer would be the ideal with a minimum of 8 cores and 32 gigs or more of memory. Fast local storage. So I would say that having an SSD or an NVMe disk would be really important, and about 2 terabytes or more. So your basic hosted applications, none of them are particularly big because containers don't take up a lot of space. And in fact, I've never really ever created a container that takes up more than about 20 gigabytes of space. It's not like building an operating system from scratch. And so containers are pretty lean and mean on storage. But I want the storage that they have to be fast storage. So that's why the SSD. So therefore, by that means storage is secondary. The server should have one or more Ethernet adapters, and as I mentioned previously, not used over Wi-Fi. Why more than one Ethernet adapter? Well, more than one Ethernet adapter will give you the capability to have that server communicate over one or more networks, otherwise known as VLANs or virtual LANs. And that's really handy. The other thing that you can also do is you can also think about aggregating Ethernet connectors for more bandwidth. And finally, UPS backup power. We mentioned that earlier. Backup power is really important, both for the health and safety of your servers, and also a little bit higher reliability so you can get through that 5-minute glitch when somebody has a problem with the actual connection to the power grid. So I have a recommendation here. This is somewhat overkill, but this is if you really wanted to go out and get something really fantastic. This is a 1U rack mountable server, and it's a very small form factor, and it is a very shallow server and very low power. It only uses about 40 to 50 watts configured pretty typically, even running full bore. It has 4 1 gigabit LAN adapters, and then for management, also an internal IPMI adapter so that you can configure it from scratch without having to have like a KVM switch. It's got an 8-core AMD EPYC data center processor, which is embedded, which means it's soldered to the motherboard. And then it has 4 DIMM slots, which will offer up to 512 gigabytes of ECC LRDIMM. Of course, that can make it dramatically more expensive memory costs, right? And then it has a 1 M.2 connector on the motherboard, and it also can host up to 4 2.5-inch SATA drives, and I believe 2 3.5-inch drives instead, if you didn't want the 4 2.5-inch drives. And again, I recommend SSDs for those things. And so overall, the device itself without memory and drives is about $1,300. So I figure, you can probably build one of these servers configured fairly nicely for around $2,000. Kind of depends. So what do I use for data storage? Preferably over 2 terabytes or more of RAID 1 SATA SSD. So RAID 1 is mirrored storage. And the reason I say mirrored storage is because if you have an SSD die, you don't want to lose all of your data. And by having 2 of them run mirrored, then you can go ahead and be sure that any failure will not lose all of your data. I mean, of course, we can back this stuff up, but we want it to be able to run real time and be able to live through particular instances of issues coming up. I say an SSD or M.2 for the VMs. Or containers, as well as the host OS. So, and that's the thing, these don't take up a lot of room. I would think having a couple of terabytes of storage would generally be just fine. So spinning drives are good for load media, things like the ISOs or the ISOs to load operating systems from scratch, like if you wanted to create a virtual machine, or even the image containers that are downloaded from the repositories for LXC or LXD containers. And so some kind of ISO storage or large storage area, that doesn't need to be on your SATA drives, or not on your SATA drives, on your SSD drives. So maybe a second tier of spinning storage. And I personally like mounting that storage elsewhere in my network via iSCSI. If you don't know what iSCSI is, you got to look into it. Basically, it's a way to provide really high-speed performance as though it is a local drive, but network-based. So network speed is more important than drive speed. Consider link aggregation. That's why I always say that it's nice to have a server host that has more than one network adapter on it. And if you do, and they're gigabit adapters, then consider link aggregation using 802.11 or 802.3 AD to improve access speeds. And, it's not hard to link aggregate things. I don't really mention 10 gigabit here because 10 gigabit would be the great way to go, but it's still rather expensive in the marketplace, and link aggregation is pretty inexpensive. So that's something to consider. So the next thing you're going to need after you've got a host is you're going to need a domain name. So you've got to go out. There's many domain name service providers. Google and Cloudflare are amongst the largest. I personally use Google. And domain names cost as little as $12 a year. It kind of depends upon the domain name you choose. They can range in price, but they can be pretty inexpensive. Like I said, $12 a year is not uncommon. So that's not a lot of money. And domain names are needed to provide a name for your services. And as an example, I have a Discord server. Not a Discord server. I have a discourse server at discussion.scotti-BYTE.com, which is my domain name. And so you have to have a way to name your services because people aren't going to want to get to them by IP address. So Homelab users typically have internet service providers that grant one changing IPv4 dynamically granted IP address for your router's WAN interface. Domain names can be made to follow that address with a dynamic DNS client, otherwise known as DDNS. So once you have a domain name service and you have your own domain, that domain name service will provide you an ability to define an A record that is also a DDNS record. And so you'll be able to run a DDNS client on your network to define that. We'll talk a little bit more about that later. So the next thing you need is reverse proxy. What in the heck is reverse proxy? So reverse proxy is a way to provide more than one subdomain name service behind a single ISP granted IPv4 WAN address. Remember, your ISP only gives you that one IPv4 WAN address, so you need a way to be able to provide more than one service behind that one address. So as an example, I have www.scotti-BYTE.com, which is my web server. I have my discussion.scotti-BYTE.com, which is my forum, and I have my chat.scotti-BYTE.com, which is my Rocket Chat server. And by the way, you all are welcome to join these servers and look around. I publish blogs all the time and lots of information out there that I hope will be of use to people. Reverse proxies can also be used to point to more than one server providing a service, and the access can be load balanced. For example, when we go to google.com, that's not just one server out there, that's a whole bunch of servers, and they have a load balancer in front of that, and it can translate to many different IP addresses. Popular open source web servers that provide open or reverse proxy are Apache, Nginx, and Caddy. And so my personal favorite is a product that's called Nginx Reverse Proxy Manager. And there I have the URL to it, nginxproxymanager.com. It's Nginx, but it's Nginx front-ended with a very nice GUI. We'll talk a little bit about that later. But there's also some great videos on the net that go into configuring Nginx Proxy Manager and everything it can do. So the next subject is containerization. That's the next thing we're going to need, because presumably we don't want to buy 10 servers and have them running at our house because, well, we don't have to want to worry about all that electricity, all that heat, and all that expense. So a container can be a virtual machine. It can be a VM. It could be an LXC or LXD container, otherwise pronounced Lexi and LXD properly, but I tend to call them LXC, LXD. Or it can be a Docker container. Virtual machines emulate all of the hardware, the OS kernel, and the OS in software. They allow you to run any OS, and they're very resource heavy. So if you build a virtual machine, you're going to download basically an ISO image and install that ISO image on a virtual machine just as though you were installing it on a regular computer. And that's how you're going to go ahead and build your virtual machine. And virtual machines, they're more expensive in terms of the fact that they use more resources. On the other hand, Lexi and LXD containers run only Linux OS instances. So although you can have a virtual machine that might run Windows Server or Windows Desktop, you can't have a Lexi or LXD container that runs Windows 10, for example, because they only run Linux OS instances. Also, one of the things that makes them very efficient is they share the host kernel And for that reason, they're very fast and very efficient. They don't really have to boot up because the main host machine's already booted. And you can install an application on a LXC or LXD instance as though we're a bare metal computer. I mean, you can log into one, it'll give you a prompt. You can't really differentiate it from a real piece of hardware, and that's one of the beauties behind LXC and LXD, and that's what made me such a proponent of them. And finally, Docker containers. They're pre-built appliances that have every component an application requires. So Docker containers are volatile, which means you can bring one up, and when you bring it back down, it doesn't really store persistent data. And the way you get around that is when you download an instance and implement an instance of a Docker container, what you end up doing is mounting external storage to it to store the non-volatile data. Otherwise, it wouldn't be of much use. But still, the really annoying thing I find about Docker containers is that there's no way to really upgrade them. When an author comes out with a new version of the container, you have to pull the new version of the container down and then run from there. And a lot of times, because it's not an update, it's more of a destructive process. I've lost data before. You have to be very careful. I mean, but the upside is that Docker containers, I mean, they just kind of run and they don't require any installation on your behalf, so they make it really easy. So what about Nginx Reverse Proxy Manager? I call this the secret sauce of self-hosting. So Nginx Reverse Proxy Manager is a front end to manage reverse proxy, and it has the added benefit of being able to also manage Let's Encrypt self-signed certificates for SSL encrypted traffic. So if you go to your websites out there, you know, almost all websites nowadays are HTTPS, and that means that they use SSL encryption, and that means that if anybody's sniffing your packets, they can't read the data inside them. And that's really good, and that's really secure, and that's really important. So self-signed certificates give the self-hoster a way to encrypt things, and that's great. So this is the main screen for my Nginx Proxy Manager on my self-hosted environment. And on my Homelab here, I have 42 proxy hosts defined. So you can imagine that it's an addiction. Once you get started, you keep creating more and more self-hosted applications. And, you know, that's a good thing. They really will get you looking around. And that being said, there's literally thousands of open source self-hosted apps. I mean, they don't cost you anything. It may take a little bit to try to get them up and running. But fortunately, one of the beauties of the self-hosted community out there is there are lots of people in forums to answer questions for you and help you out. So this is an example of how a detailed entry in the Nginx Reverse Proxy Manager looks. And you can see here that this is the one for my web server. It says the domain name's www.Scotti-BYTE.com. It says that it should connect to it via HTTPS. And that address there happens to be the local address on one of my local VLANs where I host my external services. And that's a NAT address. Nobody on the internet ever sees that. It's just that when they touch my Scotti-BYTE.com domain and they have www in front of it, or even if they just have Scotti-BYTE.com, it routes them over to the web server. And examples of others is like, for example, we talked about discussion.Scotti-BYTE.com. If it saw the name coming in as discussion, it would route it to a completely different server, and it'd be a completely different definition down here. So this is really pretty powerful. Nginx Proxy Manager has lots and lots of other services, but there's some really great videos out on the internet that explain all the other services. But I wanted to show you the basic functionality without getting into it too deeply. So the next thing you're going to need is dynamic DNS. We talked about that a little bit earlier. Usually your ISP provides you a means of having a DNS record for your domain name. Okay? So when I say your ISP provides you a means, they don't really provide you a means. I meant to say your DNS provider provides you a means of having a DDNS record that can be in there. Your ISP, they just like giving you a record that can change all the time. So that's an interesting little aside. So I use Google Domains, and here's an example in Google Domains. When I go into my DNS here on the left side, you can see it says I'm in the DNS section. And one of the things in the DNS section is I have a DDNS record, and it says hostname Scotti-BYTE.com is an A record. It's really a dynamic DNS A record, and it points to an address. And that's how it works. So pretty powerful capability. So on the other side of that dynamic DNS record, we have to have a dynamic DNS client. And usually your router provides a means to define the DDNS record as your WAN address changes, as your ISP changes that WAN address. Like, for example, if you unplugged your cable modem for 2 days and plugged it back in, you might very well get a different WAN address. And so you have to have something that takes care of that in the self-hosting world. And having a DDNS record up at your DNS host for your domain name, Scotti-BYTE.com, in my particular case, is what really counts. But then you have to have a client running on a computer or on your router of your network itself that will basically update that address anytime that address changes. So in my particular case, I use Ubiquiti Unify network gear, which is kind of a prosumer class of gear. It's very popular. And if you go here under their configuration section and their advanced features, they have an area for dynamic DNS, and it lets you create dynamic DNS entries for various things. So if I hosted more than one domain, I could create more than one. And you notice here it's saying, hey, define the name Scotti-BYTE.com and use domains.google.com to do it. And I don't want to drill down into the entry, but basically it has username and password that you're given up at the DNS service provider end, and then it just goes off and runs to do this. Afraid is one of these virtual services. QNAP just does strange things in that they won't let you enter a record with any custom names. So it doesn't matter what name of the service you pick. It just matters what host name it's authenticating on, and what name you're trying to define and what the username and password is. So that's where I do that. People have questions about that when they see my configuration. So, container server. Well, my server for containerized applications is a QNAP NAS. So there's lots of NAS units out there that are on the market. I spent all this time earlier talking about an independent server that you'd buy, a computer. But the other thing you should know is most of these NASs like QNAP and Synology, they have a built-in containerization in them. And that's something that you should really be aware of. So mine happens to be a QNAP NAS. So QNAP has two programs. One's called Virtualization Station, and it handles VMs. And it has another one called Container Station, and it handles the management, creation, deletion of LXC, LXD, and Docker containers. So this is what Container Station looks like. This is like on my smaller backup NAS. I've just got some containers built out here, and these are examples of them. In this particular case, there's one Docker container that's running a open source software called Your Backup Server. And then I have 4 LXC containers that just happen to be Ubuntu servers is what they are. And so Ubuntu servers have a command line. They don't have a GUI because we want these things, again, to be lean and mean. We just want them to run programs. We don't have users signing into them and doing things interactively with them. Everything is accessed via a web server for these hosted applications. So that being said, I guess you can already figure out that my go-to is basically LXC and LXD containers as opposed to virtual machines. And I try to use them whenever possible. So LXC and LXD provision very quickly, and you can provide them a memory cap and also a percentage host CPU cap. So I can say something like, well, I'm going to create this LXC container, and I want it to be able to allocate under load as much as, say, 2 gigs of memory, 2048 megabytes, and I want it to be able to use maybe up to 10 or 15% of the overall CPU of my host. So that's what you can do with LXD, which is really nice. They only virtualize the OS, and they don't virtualize the hardware. Remember that virtual machines, they virtualize the hardware. So you basically have emulated in software on a virtual machine. You're going to end up emulating the motherboard, the Ethernet connector, keyboard, hard disk, everything. And there's a lot of overhead in virtualizing all of that. So LXC and LXDs can be imaged, snapshotted, or cloned, and that's a real power of them because you can always take a point-in-time backup of these things and build another one just like it, or just use it as a backup. And they look like a dedicated Linux OS. So you can install any components and any dependencies to a LXC, LXD container, which may be required by a particular application. So I see this as being a lot more powerful than Docker, unless, of course, you find a Docker container out there that does exactly what you want it to do. By all means, run it because it's easier. But when you want to do something kind of customized, or you have a lot of different moving parts in something you're installing, then clearly LXC, LXD is the way to go. And plus the fact that when you have a LXC, LXD container, you can do things like a sudo apt update and a sudo apt upgrade, and it works. And you don't have any such thing like that in Docker. Like I said, these LXC containers, they look a whole lot more like separate standalone machines. So as an example, you could build yourself a template LXC container that would have, it would be Linux. It might be Ubuntu. It might be Debian. It could be just anything you want, as long as it's a Linux kernel base, because it's going to use the kernel of the operating system. So in my particular case, it uses the kernel of my QNAP NAS. So Linux, Apache, MySQL, and PHP are well known as a LAMP stack. A lot of times when you look at this self-hosted software, it says, hey, to install this software, a prerequisite is install a LAMP stack. So you can build a container that has a LAMP stack in it and just access that container, clone that container anytime you want to go build a new application that requires it. So I've even run Docker containers inside a LXC, LXD instance. And there's a lot of cases where you might want to do that because there's instances where it's easier to upgrade the Docker container if the Docker container resides inside of a dedicated host. And LXC, LXD are dedicated hosts. And there's really not any overhead of doing Docker inside of LXC. A lot of people I hear on the internet will tell you there is, but I've not really run into too many. So the only shortcoming of LXC, LXD, and there's always a caveat because, right, if something runs this fast and this great, why would anybody ever use VMs? Well, it's because you're limited to the features of the host kernel, whereas a VM can even have a custom kernel since it's all software. So where does this come across? Well, I had a friend that I tried to install an application in LXC recently, and his kernel lacks support for C groups. And C groups was something that was required for the application we were wanting to install. Another example is I was trying to put a WireGuard instance in place on my network, and as it turns out, my QNAP NAS had an older Linux kernel, and that Linux kernel did not have kernel support for WireGuard. So what I did instead was I had to create a virtual machine that had my WireGuard configuration, because it would make the software in kernel make a software kernel that did contain the support I needed. So these are examples where you might want to go back to a VM. But overall, try to go for those LXC, LXD containers, because they really save a lot of resources. Okay, so I like this one. Host, but virtualization host? Yeah. So I said my virtualization host is a QNAP NAS, but both QNAP and Synology NAS units provide support for virtualized containers. Bare metal servers, if you're going to buy one of these servers like I mentioned earlier on, or you have an old computer that you want to use, they're going to have to run a virtualization platform. And some examples of that are VMware vSphere, which is a really high-end commercial product that's used by commercial corporate data centers. VMware ESXi, which is another hypervisor, and it's basically available for anybody to use without license fees. Citrix Hypervisor is another example of a commercial product, and Proxmox is another example. So all these virtualization platforms or hypervisors are all host-level operating systems, and they're the operating system as opposed to an installed application. So let's say you take your machine that you've got, and you turn around and you have this bare metal machine. You say, well, I want to do hosting on it. So the first step is we want to turn it into a virtualization host. So if it has Linux running on it, if it has Windows running on it, we're going to wipe out that hard disk, and we're going to install something. We're going to install a hypervisor of one of these types, because it will become the operating system. So the advantage to that is that these are all type 1 hypervisors. Type 1 hypervisors are hypervisors where you don't have the virtualization running on top of a host that then runs an operating system. Instead, you have this software running that its pure reason for being in life is to run virtualized container instances. And so that's as opposed to something like Oracle VirtualBox, which is a type 2 hypervisor. You know, I got Windows 10 or I've got Ubuntu running, and I load Oracle VirtualBox on it, and then I create VMs underneath it. Sure, that works, but it's a type 2 hypervisor, and it's not nearly as efficient. The other thing you should know about a type 1 hypervisor is that its management interface is completely web-based. So you can't sit in front of one of these hypervisors with a monitor connected to it and a mouse connected to it and a keyboard and log into it and control its interface. It's all done web-based. So basically we look at those units as being headless units. They sit out on your network and you manage them remotely from your desktop computer. So I recommend Proxmox. Proxmox, if you're going to have your own hardware, Proxmox is fantastic. It's open source, it's well maintained, and it easily supports VMs and LXD containers. Proxmox does not directly support Docker, but what you end up doing is you either install a virtual machine, or you install a LXD instance, or you just you install one of those instances, and then what you go ahead and do is you go ahead and load Portainer. And once you have Portainer loaded, then that Portainer instance, which is an LXC instance or a virtual machine instance on your Proxmox, lets you manage all of the Docker containers on the same device. And if you haven't looked at Portainer, it's a really fantastic product. Portainer even manages Kubernetes clusters, which means that it can manage and handle load balancing between multiple Docker hosts. And it's a really slick operation because it's very transparent. If you had 3 Docker hosts, and one of them went down, it would transparently migrate the running app from one to another. So basically, you can invent clusters, and they're just fabulous. So I highly recommend Proxmox. I highly recommend Portainer. So in summary, host on which to install virtual containers. So that's one of the things you're going to need. You need a host. You need a piece of hardware to install all this stuff. You need a piece of hardware to install that Proxmox, right? Secondly, a registered DNS name. Yep. Thirdly, the first hosted app. What's the first hosted app? Nginx Reverse Proxy. Why? Because Nginx Reverse Proxy is the thing that goes ahead and lets you define multiple services on your network. And then you want to register a CNAME subdomain records that point to your domain. So CNAME records are what are called alias records. And so, for example, Scotti-BYTE.com is my domain, and that's also my DDNS A record. Chat.Scotti-BYTE.com is a CNAME record that points to the Scotti-BYTE.com DDNS record. So therefore, if my WAN address changes, chat.Scotti-BYTE.com will always know where it is. And that's really important for this to work. So let Nginx Proxy Manager maintain all your Let's Encrypt self-signed certificates. So one of the huge deals is when I first started doing this way back when, a few years ago, I would install a self-hosted application, and I would install a certificate on server A, another one on server B, another on server C, and nothing was managing when the certificates expire. And Let's Encrypt self-signed certificates are free, but they expire every 90 days. And the beauty about Nginx Proxy Manager is it gives you one place to go, and Nginx Proxy Manager manages the expiration and renewal of all these certificates. So that's really fantastic. And then find out about the great open source applications you can self-host on Brian's channel called Awesome Open Source. Brian is a fantastic guy. He's gone out, he's done some really great work. He's got videos that are anywhere between 15 to 30 minutes or so a piece, and they cover individual open source applications that you can install and get running in your environment. Sometimes he self-hosts them. Most oftenly, he puts them on something like a public Linode server or whatever, DigitalOcean. But he does some really great work there, and his videos are highly informative. I really encourage you to go off and support his channel. And then visit my discourse forum at discussion.Scotti-BYTE.com. I post a lot of blogs on it, and I encourage people to register and go out and ask me questions about what I've posted. It's all fairly new content, so that's a good thing. Next, I have a Rocket Chat channel at chat.Scotti-BYTE.com. You can also register on it. You can ask me questions, and I'll pretty much respond just about any time when I see it. And then finally, I have a web server at www.Scotti-BYTE.com. And when you go there, make sure and check the blog section, because I have a lot of blogs that I've written on some pretty basic stuff as well that you may find interesting in your environment. So anyway, thank you very much. And be sure to like and subscribe. And we will hopefully be talking again soon.